Greetings, wonderful math students, from Mrs. Marcellus. In this lesson, we are going to compare ratios. Today's learning objective is students will use ratio tables to compare ratios and solve problems. There is no new vocabulary to record, so let's go right to our first problem. Robert had 3 hits for every 8 at-bats. Franklin had 4 hits for every 10 at-bats. Who has the better hits to at-bats ratio? We can use ratio tables to solve this problem. We can create equivalent ratios in our table by multiplying both the hits and the at-bats by the same number. In Robert's table, we can start by multiplying 8 times 2 to get 16. If we multiply 8 times 2, we also have to multiply 3 times 2. And we can see that Robert has 6 hits in every 16 at-bats. To get from 3 to 9 in the hits column, we would multiply times 3, and we would also have to multiply 8 times 3, and we can see that he has 9 hits for every 24 at-bats. To go from 8 to 40, we'd multiply times 5, and in the hits column, we'll also multiply by 5, and we find that Robert has 15 hits for every 40 at-bats. We could continue the table in this manner, but hopefully we'll have enough information to answer the question. We have to find a place where both Robert and Franklin have an equal number of at-bats. Let's go over to Franklin's table. We can start in the hits column by multiplying 4 times 2 to get 8, and 10 times 2 to get 20. We can multiply 10 times 3 in the at-bats column to get 30, and 4 times 3 to learn that Franklin has 12 hits in every 30 at-bats. Next, we would multiply 4 times 4 to get 16 hits, and we'd multiply 10 times 4 to find that that is 40 at-bats. Now that Robert and Franklin each have an equal number of at-bats, we can see who has the better hits to at-bats ratio. Robert's ratio is 15 hits for every 40 at-bats. Franklin's ratio is 16 hits to every 40 at-bats. Therefore, Franklin has the better hits to at-bats ratio. Let's look at the tables in another way. Every time Robert had 8 at-bats, he got 3 hits. So, you could also complete the table by adding 8 at-bats plus 3 hits over and over again until we get to a point where the number of at-bats for Robert and Franklin are equal, so we could compare. You see the consistent pattern down the side that we are adding 3 hits for every 8 at-bats. That is an alternate way to complete this table. The same goes for Franklin. There is plus 4 in the hits column and plus 10 each time in the at-bats column. Let's take a look at another example. Only certain types of fish can live together in an aquarium. The first tank has a ratio of 4 guppies to 5 mollies. The second tank has a ratio of 2 angelfish to 3 mollies. If there are 15 mollies in each tank, which tank has more fish? Again, we can solve our problem using ratio tables. In the first tank, we have a ratio of 4 guppies to 5 mollies. We can create equivalent ratios by multiplying both the number of guppies and the number of mollies by the same number. 4 times 2 will give us 8, and 5 times 2 will give us 10. There are 8 guppies to 10 mollies. Next, we could multiply 4 times 3 and learn that we have 12 guppies. 5 times 3 is 15 mollies. The question asks, if there are 15 mollies in each tank, which tank has more fish? We have enough information in this table to answer the question. Let's go to the table with a ratio of 2 angelfish to 3 mollies. We can complete this table in the same manner. 2 times 2 is 4. 3 times 2 is 6. there are 4 angelfish to 6 mollies. 3 times 2 is 6, and 3 times 3 is 9. 4 times 2 is 8. 4 times 3 is 12. 5 times 2 is 10. And 5 times 3 is 15. In the first table, we also could have filled it out by consistently adding the ratio of 4 guppies to 5 mollies. 4 plus 4 is 8, and 5 plus 5 is 10, and then add 4 more to get 12, and 5 more to get 15. We also could have done this for the angelfish to mollies table, where we would consistently add plus 2 and plus 3 all the way down to the bottom. Now let's answer the question. If there are 15 mollies in each tank, which tank has more fish? The first tank with guppies and mollies has a total of 27 fish. 12 plus 15 equals 27. The second tank that has angelfish and mollies has 25 fish. 10 plus 15 is 25. The tank containing the guppies and mollies has the most fish. Let's do one final example. Lori bought a bagel assortment that has 6 oat bagels for every 2 blueberry bagels. Stella bought a bagel assortment that has 9 oat bagels for every 5 blueberry bagels. Each girl bought 10 blueberry bagels. Who bought more bagels? Let's complete our ratio tables to solve the problem. We know that Lori has 6 oat bagels for every 2 blueberry bagels. We can enter that information to start our table. For every 6 oat bagels, Lori has 2 blueberry bagels. That means if she has 12 oat bagels, she will have 4 blueberry. Every time Lori adds 6 oat bagels, she will add 2 blueberry bagels. Our next ratio is 18 oat bagels to 6 blueberry bagels, then 24 oat bagels to 8 blueberry bagels, and finally 30 oat bagels to 10 blueberry bagels. In Stella's assortment, she had 9 oat bagels for every 5 blueberry bagels. The next ratio would be 9 times 2, which is 18, and 5 times 2, which is 10. We don't need to complete the rest of the table because the problem tells us that each girl bought 10 blueberry bagels. Once we have that information, we can solve the problem. Lori bought 40 bagels. She has 30 oat bagels plus 10 blueberry bagels, which equals 40. Stella only bought 28 bagels. 18 plus 10 is 28. Therefore, Lori bought more bagels. This concludes our lesson on comparing ratios using ratio tables.